Hello, AI engineers. It's nice to be here, and thank you so much for tuning in for the talk. In the next 20 to 25 minutes or so, I'll present a report on the current state of open LLMs in 2025. And hopefully you'll be inspired to try them out by the end of the day or by the end of the talk. Let's see. So when we talk about open LLMs, like one of the first questions that pops to the mind is like, how do they stack up against the likes of GPT-5, the likes of Claude Sonnet, and so on and so forth? Thanks for us, there is an evaluation service, or rather a company, which has made it its mission to benchmark closed as well as open models against standard set of evaluations. What you see on the screen is the average performance of recent LLMs on a bouquet of evals, ranging from math, coding, scientific rigor, and so on and so forth. The black bars that you see are proprietary models, and the blue bars that you see are open models. And what you can see right now on the screen is that in the top 10, there are pretty sizable amount of open models. So I can see 3 or 4 here. And if you look at it in absolute scores, the open models are actually quite close to the closed models as well. You can see that GPT-5 high currently, with like reasoning effort high, is at 67 absolute score, whilst GPT-OSS, another open model from OpenAI, is at 58. And there is a small caveat here, is that whilst the open models are tracking proprietary models quite closely, the closed models on the screen that you see come at a higher cost, as well as at like a higher token budget, meaning like you have to reason for longer and so on to get to the same stage. Whilst now we've established that open models are sort of OK, the next question comes is like, are these easy to use? Surely, like, you have to deal with like model weights, you have to deal with different runners, you have to deal with setting up your virtual machine, and so on and so forth. So surely this must be like difficult to deal with. Well, let's look at it. There are typically 3 ways of like working with open LLMs. Number 1 is a serverless API. This is similar to how you would interact with OpenAI, with Anthropic, with Gemini, and so on and so forth, which is essentially that you take like a 5-line snippet, you give the model ID, and you pass a prompt in, and you get some sort of generation out. Second is a managed deployment, wherein you select the model weight, you click on a few buttons, and automatically this a provider, this could be similar to Modal Labs, could be similar to Koyab, Hugging Face, and so on and so forth, would package these model weights up, and you get an endpoint out. Or last but not the least, since you have the model weights themselves, you can deploy it yourself. Which means that you set up your own virtual machine. This could be a VM right in your basement, or it could be a GPU cluster on AWS, Google Cloud. Pick your favorite cloud provider, or at your company, and so on and so forth, and you set it up. Now let's look at these in a bit more detail, right? Let's talk about the serverless API. I'm pretty sure everyone in this room would have dabbled around with a code snippet similar to this. This is like a boilerplate OpenAI chat completions code snippet that you would use to interact with GPT-4, GPT-4o, GPT-5, and the likes of it. In the year of 2025, we've adopted this as the standard. Be it chat completions API, be it responses API, you can access pretty much any open LLM with pretty much the same standard. Which means you have a familiar SDK. So in this case, you can swap GPT-5 with, for example, GPT-OSS, or could be like one of the latest Quen models, and so on and so forth. you can choose by a bouquet of routers. So you could use Hugging Face inference providers, Open Router, and there are many other providers like this. So there is quite a lot of optionality for you. Um, and that's it. And then just like plug in your prompt and just go about and build your application. So it's pretty much the same experience as the frontier models, which are proprietary, and so on. You can go one level down the stack as well, which is what we were talking about in managed deployment. In this case, you typically go to a LLM market space. This could be, Hugging Face inference endpoints, Lambda Labs, Prime Intellect, Modal. There's a lot of competition. There's a lot of healthy competition out there, healthy providers out there, each trying to give the best sort of service to you. Pick your own GPU. This could be an H100, A100, T4, L4, whatever works with your budget size, whatever works for your specific use case. And that's it. And then just deploy. Like in most cases, it is as the image on the slide is. You pretty much just select a model. In this case, we select Qwen Next, and you just hit deploy, right? And that's it. And within like 2 or 3 minutes, you have a deployed endpoint that you can then use. Last but not the least is how to use is if you want to sort of deploy these models yourself. You might want to do this in case you want to have the maximum control. You want to sort of make sure that wherever your prompts go is something that you want to have full control on. You want to make sure that the model abides by your specific rule cases and so on. In this case, you would typically start by choosing your own inference engine. There is a huge variety of inference engines, namely VLLM, SGLang, TGI. There's a lot of other like niche inference engines which you can choose from. Once you've choose these inference engines, you provision your own sort of cloud GPU cluster. This could also be just like a GPU lying in your basement, and you set it up, and that's it. And you have like a private and secure deployment. Each of the 3 sort of ways that I spoke about have their own utility, right? So if you want to like run fast, you would probably want to start with something which is serverless. If you want to have a bit more control and you want to make sure that the net intelligence that you supply to your app without having like a dedicated DevOps or MLOps team, then you might want to look at managed deployments. If you want to have like really a lot of control on like what is going through, you want to have full provenance of your prompts, you want to have full provenance of your outputs, then you want to sort of have something that you want to deploy yourself. The best part about this all is that given you have the model weights, you have the optionality to choose, essentially. And you can go through the stack, you can work through the competition, you can work through all the platforms and so on. But now you might be asking, like, why do I even need so many deployment options, right? This is a classic sort of buy versus build sort of argument. No matter where you are in your sort of like life cycle of a startup, of a business, and so on, you want to always increase the optionality that you have with respect to what you're providing, right? So in case like your startup or your application depends on LLMs, you want to have it. You want to always have like one failover over the other. You don't want to always depend on just one provider. Case in point is the recent issues faced by Anthropic. No shade to Anthropic. I use Claude every day. If there's someone here from Anthropic, I love you guys. But this is a recent blog post from them, which was about the timelines of issues that they faced while serving Claude Sonnet, as well as, if I'm not mistaken, Opus models. And the issues here specifically was that they had like an issue with like context window. They had an issue with the way they were routing the prompts. And what all of this led to is that you were calling the Anthropic models the same way as you were, but a small percentage of these requests were not being fulfilled the way they were supposed to, meaning you were getting like slightly lower quality outputs at the end. Given you have no no sort of visibility into what's going wrong, this can cause like quite a bit of issues. Because without having any visibility on what's going wrong up the stack, you just get degraded outputs. And this is something that, based on whatever use case you're working on, you would want to optimize, right? And of course, like we've all heard the lore, right? Like Sonnet is dumber during the day, but it becomes much smarter during the evening. Like when you're coding in the night, like Claude Sonnet is much nicer, and so on. And of course, a lot of this is placebo. But the fact that we don't really have access to the model weights makes it much difficult to be able to narrow it down to one thing. And as one of my favorite researchers that I look up to quite a bit, Andre says, not your weights, not your brain. And again, like you want to have as much optionality as possible, and so on. So now that we've established that open LLMs are good enough, open LLMs are there are quite a lot of options for you to use these LLMs. Let's look at some of the recent trends in the open LLM landscape. So we'll go through 3 trends. The first one is up until like last year, up until December of 2024, OpenAI o1 was the state-of-the-art reasoning model. And when they released the model, it was one of the first sort of thinking model, in the sense that before you get to the final response, the model sort of contemplates about the response itself, and because it contemplates, you get a higher quality of output. When they released the model, they decided to hide these chain of thoughts, or like this contemplation, from the model itself. Fast forward to January of 2025, DeepSeek, one of the key LLM players from China, released DeepSeek R1. This was a very huge 685 billion parameter model, MIT licensed, meaning you can use it for commercial use cases. You can use it for any of your own bespoke use cases. They released this model, which was competitive with OpenAI o1, with Gemini at that time, and a lot of other models. The best part about this was that they opened the entire chain of thought for anyone to use, which means that chain of thought was not sort of commoditized anymore. Any sort of open participant, any startup, any business could have the same sort of capability of getting higher result from the same model from there on. In fact, they didn't just stop there. They proved that because the chain of thought is now public, you can distill this chain of thought to smaller models. The way they proved this was by distilling the R1 chain of thoughts into a smaller Qwen 8B LLM. And to their surprise, when they trained it specifically on math, this model beat a 25 times larger open model. So that's an 8B model sort of beating a 235 billion parameter model. And this is where the sort of reasoning revolution sort of started in this year. And now pretty much reasoning has become like a standard across all models. In fact, the recent GPT-5 series models, all of the models have reasoning, except they have like a reasoning effort. So the models can have low reasoning effort, medium reasoning effort, high reasoning effort, and so on and so forth. And pretty much all open models have a thinking variant, have a non-thinking variant, and so on. Next, in general, LLMs are as good as the amount of context you give them, right? So the more context you give them, the better they would be at their downstream task. Let's say you want to summarize a research paper. If you just provide the abstract of the research paper to the LLM, the output itself would be quite suboptimal. But at the same time, if you, to the same LLM, with the same prompt, if you provide the entirety of the research paper, the summary of the research paper would be much more guided, would be much more on point, and so on and so forth. What this means is that these LLMs require a ton of context to be effective. Back in 2024, your average open LLM had a really small context. So 32K to like 64K tokens was kind of like the standard. Like, you would see your Llama, you would see your Quen and Gemma and so on, and they would pretty much range around 32 to 64K, which means that they were good enough, but they weren't really like useful for like large context tasks, as OpenAI was or probably Anthropic was and so on. Fast forward to 2025, 128K, 256K has become the standard, which means that now all the other use cases that you had to previously depend on proprietary models for, you can do the same with like open models. And not just that, 1 million context even is now feasible. This is also feasible with like proprietary models, so this is not something new, but we have Quen models which are capable of 1 million context. We have Llama 4, which is capable of even 10 million context. So you really are now not bounded by the context itself. You can really like just try a lot of these experiments. As we started sort of increasing in this context, right? Like as we started being able to sort of squeeze in as much information to these models, there was another interesting trend, which is that the cost of these models also started decreasing. A lot of this sort of came from like optimizations at the software level, at the hardware level, as well as at the architecture level. But the fact of the matter is, if you had €1 or $1, you get much more bang for buck now as you got the same time last year, right? This is again like a chart explaining the same thing from the good folks at Artificial Analysis, and so on. Heading to the third trend, back in 2024, open LLMs required a steep learning curve. There were a lot of problems. So for you to be able to deploy a local LLM, you had to look whether or not the chat template is correct. So chat template is a way in which your model learns how to map an input to an output. So if you say, hey, summarize this paper, it would take this, it would format it in a way that the LLM understands, and then you get an output. And these were quite malformed. We didn't have any sort of standards. Tool calls were very difficult. We had model precision issues. So essentially, like we didn't know like what was the model trained, like whatever precision the model was trained on versus like whatever precision the model was deployed on. So there were quite a lot of issues like this, and of course, like there was latency issues and memory requirements for those. Fast forward to 2025. We now have standards for chat templates. So everyone has defaulted to chat-ML format. 4-bit and 8-bit quantization has become first-class citizen. In fact, like all the new LLMs that you see are pretty much FP8 first, which means that you do not require as much VRAM on your GPU to use these, and these are native, which means that you don't really like lose out on any of the performance. And in fact, now with the recent OpenAI GPT OSS, we've seen that 4-bit is also becoming kind of like a standard. But surely there has to be a catch, right? Like all of this is too good to be true, right? And in some cases, maybe it is. Let's look at where do proprietary models still win today. First of all, for general reasoning. So what we've seen is that open models are very good at certain specific tasks. So you would see open models being really good at, for example, tool calling, really good at math, really good at science, really good at coding, and so on. But there's no like one model which is good at everything, much like what your proprietary models offer, similar to Anthropic, similar to OpenAI, and so on and so forth. So there is still a hill to climb for like general purpose reasoning when it comes to it. End-to-end multimodal is quite superior for proprietary models, and more specifically for, in this case, OpenAI. OpenAI has a huge sort of margin when it comes to GPT real-time, GPT 4.0, advanced voice mode, just the fact that you can have like an actual 5-minute chat with the advanced voice mode, tell it whether you want to go it whether you want to ask it to go fast, slow, or like ask you to teach sort of French, ask you to teach German, whatever it may be. You can just ask things when it comes to advanced voice mode and also GPT real time. This is something which we haven't really gotten to when it comes to open ecosystem yet. Last but not the least, proprietary models have a sort of very nice, well-defined safety and jailbreak scaffolding. Open models, when it comes to open models, you often have to define this yourself. You have to make sure that they are, covered from all sorts of issues or all sorts of potential jailbreaks and so on. And this is something which like proprietary models have kind of mastered at this point. So if we were to sort of summarize this in like one slide, what would be a playbook for you to simply just try open models is pick your simple project, any project that there may be, swap the proprietary with the open model, evaluate on the same tests that you have been evaluating on, iterate, swap with another model, tune your prompt, and let it rip, pretty much. Last but not the least, what's next and like what is some stuff that I'm quite excited about from these trends? First of all, I'm quite excited about like smaller and domain-specific models. In the recent times, the Gemma team at Google DeepMind released a Gemma 290 million parameter LLM. It's a small multilingual LLM which can run on your browser, can run on your devices, and so on. And these sort of small domain models are, in my opinion, the way to go. Like you lower the cost, you increase the access to a lot more people, and so on. Second is effort-based reasoning. So this has started to become like a thing which OpenAI is doing, which is essentially from the same model, you can just define what kind of effort do you want from the model. So do you want like a low reasoning effort, a medium reasoning effort, or a high reasoning effort? And this effectively makes your singular model effectively 3 models, and for the same deployment, you get much more bang for the buck. Better quantization schemes, so FP4 becoming like a norm, and 4-bit quantization becoming like the go-to for all deployments. And last but not the least, like sparse and faster MOE. So at this point, we all know that all major frontier LLMs are MOE, which is mixture of experts. And the sparser the MOE is, the lesser the active parameters and the faster the inference would be. And we're seeing quite a lot of, we're seeing some trends towards like sparser MOEs, and I hope the community decides to sort of double down on that. That's it. I would recommend be close to the source, and always default to open. Thank you very much.